This world is broken. The science is outdated, the math is incomplete, and the people are so blinded by greed that they cannot see the way forward.
Wait. You're not thinking of intervening, are you?
It has to be corrected. Knowledge is not a commodity. It has been and always will be their future. Standing in the shadows is no longer an option. We have to teach them to share freely without fear of retribution.
There is too much to teach for just one person.
I know. We will have to recruit more people who think the right way. The people who have been shunned by the mainstream. People who have the passion in their heart for the science.
How do we find all of these people then?
We create an open forum to discuss ideas and build ties. We let everyone have a voice, and we never let greed dictate our path.
What do we call it then? Oh, I got it. The Fringe think tank.
The Fringe think tank it is then. Now let's give them back their destiny and open it up to the world.
Hello everyone, my name is Nathan and welcome to the Fringe think tank. We have the Benefactor here with us. Gerald will be joining us soon.
What's going on, everybody? Hi, Nathan.
Hello. We're going to be talking some dark energy today and dark matter. And do we think that dark energy is the same thing as cold energy or the ether that we're actually dealing with today? What do you think, Ben?
Well, that's an interesting question. I think it's absolutely the same thing. I think that cold energy is the influx of energy that comes from the collapsing field when you have a electromagnetic field. You have that back EMF.
So the way I would describe it is that there's a reason they call it cold energy. So let's just define what it is real quick. We're taking a normal circuit that's hot, and you run the hot through the positive of the circuit. Now we're taking the energy and we're pulling it through in a negative pull. So you could call it negative energy, or it's cold energy because we're taking the side of energy that comes off the negative terminal, not the positive terminal, and we're running it through the circuit. Therefore, the conditions of the circuit get cooler instead of hotter.
And normally that back EMF, it interferes because it's going the opposite way, right? With the signal, unless you actually resonate it properly. And then it's just like a surfer riding a wave.
Yeah, so what we're doing is we're capturing the energy into a capacitor bank, a battery, something to pull it out. So if you think of the circuit, you always have the positive that comes in, heats everything up, and turns on everything, right? Well, cold electricity works the same way, except for it's a massively high voltage with a very low amperage. So the amperage is where you get your heat because it goes so close to your wire itself. So if I took this right here, and I told you this was the wire, then my amperage would be here, but my voltage would be out here. So what does that do? Well, the further away from the actual wire it is, the colder it is. That's why it's called cold energy. It's also why it's negative energy, because now we're pulling the voltage side and we're not pulling the amperage side. Traditional battery, we're all knowing we're pulling amps out of it. The more amps, the more heat, the more that we see systems run. That's why it's explosion. The negative side would be implosion because you're pulling the energy into it or away from the heat. So now,
right, we're dealing with the potential rather than if you're dealing with the current that's going to increase the resistance and the heat.
Absolutely. So when it comes to space and stuff, here's what people know that's there. But they forget as soon as they start talking about energy. It's cold. When there's no planets to heat it up, there's no sun, there's no field around it, then what happens? It gets even colder. So things start moving at a slower speed out there, and the energy itself is not producing hot energy. So it changes the energy itself and how it works. So when we start talking about dark energy, that's all it is. It's the cold side of energy. And one of the reasons most people don't understand this is because physics only deals in the hot side of energy. They don't deal in the cold side of energy. They don't even recognize it. So if you ask somebody in physics, hey, what's cold energy? What's negative energy? What's dark energy? What's the ether? They have no clue because they don't deal in the correct side of energy as well as the other one. Now, take both. There's a balance there, but you're going to have to pull from the cold side in order to understand it.
Right. Conventional science just sees it as a nuisance that gets in the way of your signal, and you just need to ground it out.
Yeah. Well, they just don't understand why it's there.
They don't want to study. Yeah, they think of it as just conventional. When you look at it a little closer, like you said, it's mostly potential, and that's why it's cold.
Yep. So they always try to throw out conservation of energy, and it can't work that way. Well, conservation of energy is a closed circuit. Out in space is an open circuit.
And when you're creating an electromagnetic field and then collapsing it, you're tapping into that open circuit. You know, you're creating a pathway to that open circuit.
Right. So now what you're doing is you're actually pulling in more energy into it based on your field and how it runs. So now that you're pulling the energy into it, the energy itself multiplies. So where before you couldn't do anything with it, it doesn't destroy itself. It only moves between one thing to another. Well, that's perfect for hot energy in a perfect system until you have hysteresis, which pulls it out. And then they say, well, that's just the motion being created and expended, but it's still there. The difference in cold energy is it's pulling in the surrounding energy around it into the center of it, which makes it amplify the total amount. So all the energy is being pulled into it. Now, you're getting a higher value out of it. So the conservation of energy is absolutely the worst thing you can use here because then it doesn't apply necessarily to negative energy the same way it applies to hot energy.
Absolutely. Absolutely. Oh, we have Gerald here.
That Gerald showed up. What's up, Gerald?
Hey, Gerald.
Probably just get Gerald.
Can you hear me?
Yeah, we can hear you.
Yep.
Awesome. You're not what's that? Go ahead.
Talking cold energy, Gerald. We're talking, is dark energy cold energy?
Well, that's really debatable, but I'll say this. The physics community tried to apply that name to cold energy, but what's cold energy? All cold energy is the ether, scalar energy, the quantum vacuum. It's just a bunch of different names, all for the same thing. So you could call it dark energy for the physics community to understand what we're talking about. But basically, that's all cold energy is being able to manipulate and charge separate the energy you're working with through the ether or through dark energy. You know what I mean?
Yeah, absolutely. That's what we just got done saying for the last few minutes.
I'm sorry, I missed the first part because I was talking with my daughter. So
it's okay. What I'm trying to get across to people in a very simple way is physics looks at hot energy and a closed system, where cold energy is an open system, and it changes the physics of how it works.
Yep, absolutely.
So what I was saying earlier is you're pulling in extra energy from other places with the cold energy. So anything that's in the room is available to use because it's rotating through the system and making it colder.
And when you make a connection to that 0 point energy and then you just ground it out, you're closing the circuit again, you know?
Well, you're moving the heat or you're moving the cold depending on what system you're using to do it. Like
so you're closing yourself off from the 0 point energy that was created. Yeah.
When you're moving the temperature?
No, when you ground out all that back EMF. So you have all that potential and then it's just being grounded out. So you're closing it again.
Yes and no.
You got to see the...
Yeah, like I was saying, it depends on the system you're using. Like the system I'm using, I can ground out one side of it, still just like fill my cup, pour it out, fill my cup, pour it out. And I can do that forever while my secondary is grounded and my primary is creating the dipole. So some systems work like that and others work more like a Tesla coil, where the scalar concentrates in the center of the open core of the Tesla coil itself, which allows the manipulation of temperature, because that's where your charge separation is. Charge separation is the key to all of this. That's why. Go ahead.
Go ahead. Finish.
Well, I was just going to say that's why I said the rodent coil has its purpose, and I know it plays with a tiny bit of scalar, but it's not what I think you're looking for.
So
But
there's an update on that. Technically,
Right.
The coils that we're trying to recreate, I found out recently, they're not actually rodent coils. What they are so a rodent coil or a ABHA coil does not follow the phi ratio, but
Nope.
the PoE coil does, supposedly. And this is the new theory that we were just discussing, Michael and I, going forward, making these coils. We might want to stick with more of a phi ratio from the inner to outer diameter or something like that. Because what we see in the information that I dug up from First Stop Energy specs, their inner to outer diameters were a lot. There was a bigger difference than what we have now. So I have like a 3 to 6 inner to outer diameter. Theirs was like a 1 inch inner to 5 inch outer diameter. So it was a lot bigger difference there. So
that really makes that your open core diameter in comparison to your outer core, it's essential in what we're.
Well, my theory was closing that inner diameter more would condense the magnetic field's 0 point.
See, the thing with the rodent coil, or the way that your system is, and I'm not dissing on it at all, Ben, but your system has multiple strands all tied together, and they're wound around a circular form. So what does that mean? Well, all your plasma buildup, all your excess in between each line of copper that's on that one line is all now compressed, and it only comes out that one line. So you're not getting like a whole bunch of constructive interference. You are getting it, and you are getting extra because that line is starting to expand it a bit. But as you're twisting around your circular form, that spread out of that energy coming from all that compression is sort of dissipating.
So what I've experienced is you're absolutely
wrong,
right. No, from what I've experienced, you're absolutely right. The designs of the multifilar are not perfect at all. They are more of some of them are more proof of concepts, really. But at the end of the day, you're absolutely right in the sense that there are lots of imperfections, and it isn't the ideal. It isn't the ideal winding, right?
There's a purpose for the rodent coil, though. There is.
Okay, so
I won't say what it is here because that's not what we're talking about. But I'll get into it with you later, Ben, and it might twist your brain because I believe there's a purpose for it that's not what people are expecting. Go ahead.
So we're talking about cold energy. Okay, as much as I want to discuss the rodent coil later, what I was going to say was Ben earlier was talking about you're going to ground out the energy, right? So what it is in a hot system, when you ground it out, then you're using the law of conservation of energy. So what you're doing is you're putting a hot side into ground, you're dissipating it through the ground as heat. That's what's going on here. In a cold system, you're pulling the energy from the ground and you're adding 20% energy at minimum to your system because of the cold energy. That's the difference.
Yeah,
and some of the systems, the ground can actually be like the air, right?
It's a sink,
right?
So it's like a heat sink, cold sink. Once you start playing with temperatures, you can take the temperature out of something and use it as a voltage potential. And then that voltage potential going from a high potential to a low potential gives you all the current you want. Tesla did it all day long. He knew it, right? So you can pull anywhere, at least I've found, anywhere between 15 and 30% out of the ground extra. Because
yeah, I know that you can increase the efficiency of some systems theoretically from what I'm reading just by using a proper ground. That's what Michael wants to do. He wants to get 2 grounds and to get 2 rods into the yeah.
Yeah. I found a guy doing 3.
Interesting.
Made me think. So I'm going to play with that a little.
So just so we understand this, everything has a charge potential on it. When you're dealing with potential energy, you have to know that. Okay, it's why the double slit experiment fails when they put a camera on it, because they don't realize they're adding charge to the room and they're changing the direction of the actual light because they don't understand what light is.
So it's the instrument that's interfering with the ability to see what's actually going on, is what you're saying?
You basically, if I turn something on there and I have any kind of heat coming off of it, I'll immediately change the charge on the surface next to it.
Yep.
And
just by the very flow of it.
Just by the very flow of it. And if I change the charge potential on the table, I also change the direction it goes.
That's something they don't talk about, and it's so significant. It should be involved in the experiment itself, but it isn't.
It should be a parameter.
Yeah, I think the double slit experiment, in a sense, it's not fixed, but it's set up so that the person who's not experimenting and seeing this stuff looks at it like, oh, this is amazing. They're right. They're geniuses. But really, they're keeping half of the experiment out of the equation so you don't see it. Because if you did see it, you'd see that their conclusion is not wrong. It's just lacking.
Okay, so let's finish off this cold thing so we understand it from pulling from ground. If I told you the ground is negatively charged, and I told you that I'm pulling the negative through the system, and I told you I'm using a PNP transistor, which is designed to pull the negative, unlike Gerald, who loves NPNs to do it. So it's designed to pull the negative through the system. So what is it doing? I'm pulling the charge potential from the ground. That's what I'm doing. In any Tesla coil, they do it, and they're not telling you they do it, but it's exactly what they're doing. In order to get that extra 20%, they're pulling the charge potential from the ground. Now, it's localized. It's not as big as it could be. Why? Because they haven't pumped anything into it. They're just taking whatever it can pull from. So it's not a concentrate. It's not a, how do I say? It's not an ever expanding thing because they didn't make it that way. They didn't design their circuit that way. They have a very localized area where it pulls it from. Now, it could be clean energy. It could be dirty energy. It depends on if you ran the spike into the ground by yourself and put your wire onto it, or if you use the ground from your wall. The wall one will be dirty because of all the different frequencies going through it. Yep. Because once they get to 60 hertz, they don't care. The one from the ground will be more of the earth, and I can pull more out of the earth than I can out of a ground from a wall because they don't have destructive interference.
Yeah, I get that too. I can actually pick up like half a volt from if I'm using a power supply, it'll show up half a volt on the meter, just the ground. But if I use the pipe that goes underneath my house, I'm getting 1.5 volts before I even start anything. So, yeah. And I think it has a lot to do with the temperature differential. When you're causing charge separation and you're controlling where your temperature is going to be, whether it's in the circuit, the pickup, or the ground, you literally can define how much energy you're getting. You just move the energy, you move the temperature around, and you use that temperature differential to turn into a potential difference and then you manipulate that to ground and collect your current.
Yep.
I thought I was reading about someone using plasma as a ground. Does that make sense?
No.
Yeah, you could.
I don't.
But I don't
Plasma's
know.
a waste of energy.
Yeah.
I was just wondering, the excited gas or whatever, plasma state.
Well, to create plasma's what, 1,500 volts or more? That's what they say, something like that. I could be wrong on my numbers, but it's
I think
like
it depends on the gas, right?
Yeah, that's the thing. You're exciting gas, right? Well, if you use cold electricity, at least that's what we can call it, or dark energy, or the quantum vacuum, you're basically creating a plasma that you can't see. It's beyond our eyes to even see it. I think I'm going to give a shout out to Jeremiah Pop because him and I discussed this previous, and I think cobalt blue glass, as he was saying.
Was that one video I think I've seen? Yeah, I think he was
show this type of plasma, right? Because of the spectrum that it's at. But that's the kind of plasma you want to use because it's a subtle electricity. It allows you to build. It allows you to take your cup and scoop it out and then use it and then scoop it out. To close the loop and force all that energy into your system, let's say you want 10 kilowatts or this, that, and the other, there are other factors that come involved that you don't want to play with. That's why, like Myke Faraday research was saying, use more than 12 volts. Don't be a wuss. Well, there's reasons why this system that I use can't go over like 18 volts because it's a little dangerous.
Yeah, I knew it.
Yeah.
Yeah, that blue cobalt video was amazing.
Yeah, it was not
a really
awesome.
Cool video.
Yeah, you can see that when he does it. Okay, so I show ball lightning on my channel. And the next day, he's like, "Oh, I could do that with a microwave transformer." And I was like, "Challenge accepted. Please do." and he pulled out this cobalt blue, and you could see it better in his video because the camera can pick it up. Whereas mine, I was using like crappy camera, and I didn't have any of that.
So he just pulled out a pair of blue blockers, and
I don't know where he got it. I think it was like an old piece of glass from way back when, like the 60s or 50s that he collected, right? Like it was old cobalt blue.
Okay.
Because they used to use that in dishes, eh? Do you know that? Yeah. Part of glasses and all kinds of different things. Bowls.
So let's get back to cold energy.
Yeah, sorry.
As much as I love that other stuff.
But I wonder if cobalt blue glass would be able to allow us to see that kind of cold energy. Anyway, go on. I didn't mean to cut you off.
If there's a UFO flying using cold energy, you'd absolutely show it.
I want a pair of glasses that are cobalt blue now.
What the heck is that sound? Oh.
I don't know.
Are you hearing banging?
Yeah.
Sorry, my daughter's making fettuccine Alfredo from scratch.
Oh.
She's like a red letter chef sort of thing. So
nice. She's whooping on it.
That's neat.
Yeah, that's what you hear. So if I hear banging, I'll try and hit the mute.
So here's the thing. I'll always ask the question. They say a proton, right? Or they say that light has mass to it. And so let me ask you, why is light gone when it goes through the solar system then? Because light does not appear in the solar system. You say, okay, well, I'm looking at the sun. There's light there, right? Mm-hmm. Turn your camera 90 degrees to the right. There's no light. Okay? There's no light shooting across that sky. Okay? It's just not doing it. So what is it?
You answered your question, though.
Well, I know I did, but I'm going to answer it further. The only reason that you see it is because the cold energy in that area is hitting the hot energy in that area, which is known as the magnetic field of that area, which actually produces the light. It's a use of energy.
But still allows a channel of energy to flow from the sun to the earth in what the scientific community call a chirality movement, which is basically a spiral. Why? Because you can't have a straight line of heat or cold from the sun to the earth, because as that energy is getting pulled out, it gets cold. So it starts to turn, and then it starts to build up energy again, starts to come back to its straight line. The cold sucks the energy out, and then it starts to waver off again, and eventually just starts spiraling. Physics, right?
They asked the thing I was looking at a thing. You were talking about the speed of a ball on a ramp.
Oh, yeah.
At an angle, is it faster this way? And then the guy proposed that it had a dip in it, right? So I can't get my fingers to it, but at the very end it dipped and a little bit up. Okay, and that was be the fastest. Well, I don't think entirely it's the fastest at all. Rotation in it gives the speed, because just like a bank on a river, it pulls the energy in and then explodes it out. So you're going to get an explosion in the last few inches of it that's going to surpass the speed of the line.
Yeah, it's kind of like a build up and release.
Back to Schauberger when you think about how it works. So anyway, get back to a little bit of cold energy again. So I was trying to say the physics doesn't understand. There's hot energy and there's cold energy, and they're only exploring the hot energy in physics. So, you know what I mean? You want to talk about all the physics things they do? We're talking about the hot side of energy. If I ask anybody in physics, what's cold energy? What's negative energy? What's the dark energy? What's the ether energy? They have no idea what I'm talking about because they don't study it.
No, they don't. Either that or they're not allowed to study it. Remember, it's academia that's broken, not the people that are in academia. There's a lot of smart people out there, but the system is so broken that it's like you have to be funded to get your whatever you're doing out, and you have to write so many papers, and then once you become a PhD, you could define what projects you want to work on. But if you step out of line and don't do the projects they want, you ain't getting a penny.
No, I understand that, but at some point you got to say, if you have the yin, where's the yang?
Oh, okay? Hey, I'm with you, man. If you got the balls, you should be out there going, hey, look, this is how it works. I don't care about the community. I don't care about my paper, the reputation. This is the truth. There's not a lot of people out there in the physics community, unfortunately, don't take offense to this, that have balls enough to do that. Because you got to stick it all out, man. You got to put it on the line. You got to be aware that there are going to be people out there that are going to not believe you, ridicule you, call you this, that, and the other. So not a lot of people want to do that.
But the thing is,
my whole life, I don't care.
In order for their equations to work, you have to have the opposite side of it.
Yes.
You cannot work in the positive side only. You have to work in the negative side in order to truly understand what physics are, or else you lose most of it.
Did you see the fix on the circuit? The new
video?
Yes,
I did.
Okay. I love your comment, by the way. I knew we were doing a live, and that's why I gave just very little in it. Okay. But what you're talking about right now, about cold energy, that circuit allows you to control the heat. It allows you to control the cold energy coming into the system by controlling the heat. How? Because I take an NPN and I pull the power through the coil, and I use the positive energy or the heat energy on the back end of the circuit. All that cold energy is going into the coil, and all the heat's going from the circuit to the load. So the charge separation that happens in the center of the coil starts from cold. And both of those systems, in the temperature differential, the voltage potential difference, all that comes together.
But in that circuit you get very little heat, which you probably have seen.
Yeah, the transistors run cold. Honestly, I've had they're so cold almost that it almost burns my finger, depending on the load, how much watts the load is, and what I'm doing with the coil. Like if I have pickup coils on the outside of the big coil, and then I'm pulling a load out of the circuit, the transistors will get super cold, the coil will stay cold, and the pickup coils around the coil, you can see on the infrared camera, are a little warm, but not hot. They're not, you can't feel the warmth, but you can see it in the camera.
But you can individually turn those on and off and direct change in your entire coil by doing that.
Yes.
Well, what's funny is, go ahead.
Okay, so when it's in a certain things I don't talk about, okay, but when it's in a certain mode, I could, okay, so we'll do it like this. In a thought experiment, if it could float, of course, you know, if, and it was levitating, and those coils are sitting around it, I can pull energy out of one of those pickup coils, and it would squeeze the back end of the energy and push it forward. Or I could put energy into one of those pickup coils, and it would pull it the other way. So the control of what direction it would go, if it could float, would be controlled by those pickup coils. So there's 12 points of direction that it could be. Well,
Okay.
14 if you include vertical up and down. Go ahead.
All right, Gerald. I got two things for you real quick. Number one, my Tesla coil runs in negative energy. You probably already know that. It's a PNP, so I'm pulling the negative side to the circuit, not the positive side. So it would explain this phenomenon that I have. Okay, it would explain yours as well. So let me explain it. Okay.
Okay.
We're telling you heat in the circuit changes it, right? And we're telling you that it's cold that we're running for the circuit. I'm telling you that I'm putting negative into the ground. So I'm pulling the negative side, which I'm pulling cold energy in. Okay? There's no disillusion of any fact there. That's exactly what I'm doing. What I'm not telling you is when I add a little heat, I have now just changed the charge from positive or negative and flipped it. So by adding the little bit of heat, okay, now I have a charge difference. Now, just think about it this way. If I lower the temperature of something that's isolated, and then I add a little bit of heat to it, everything rises in heat. So as I add the little bit of heat and I add the charge difference, I'm working well with inside the Earth itself and how it's maneuvering itself to pop it up.
Mm-hmm.
That's how it's done. That's the trick. So if you don't understand heat and cold in your system, you don't understand the charge and why it changes between positive and negative in that temperature, getting it to go up in a bubble is almost impossible. So if I'm putting in a bubble and I'm telling you I'm running it cold, then I'm telling you I'm flipping the positive and negative with the heat, means that I'm putting a direction to where I want to go. Please understand that. If you want to understand how to make anti-gravity, you must understand how gravity works. Gravity is pulling down. It's pulling a negative onto the ground. You can feel it when you pull it through your Tesla coil as the negative. So it's pulling into the circuit that way. As you create a flying device, a capacitor, you're now pulling it into it and storing all of that cold energy in the capacitor. Now, all I need is a charge differential to move it. And then when I create the charge differential, I create a little bit of heat and it'll rise to the heat.
Yeah.
That's it.
Okay, but that's how it works in a Tesla coil, right? Now, it does work that way in my coil, but there's some things that can be manipulated a little bit differently.
Well, because you have more angles of manipulation.
Thank you. Yeah, it's no different. I'm not saying you've done any different. You pulled a key out of a picture that like I said, I've asked for 10 years the answer to, and you were the only one that had it. Now, when we talk about temperature, I was looking at that picture just the other day because I got a file on Philadelphia experiment. I got to go over it with you. I was some crazy stuff in there. Anyway, so that picture is in that file, and I know it was a picture that Tesla manipulated, and he was the one that put the sparks, the lightning on it and everything. But the pole that I seen that comes down the center of his Tesla coil at the bottom's open. Like what we went over in your live, I think he understood exactly what it was you're talking about. And he was using that in the end, right? Mm-hmm. So yeah, you're right. It matters. Everybody runs their Tesla coil on a table over the bottom. Why? My coils don't have a bottom. They don't have an open, they're not sealed. There's a reason for that.
Well, okay, so let me explain the Tesla coil a little more because people think they're just a sparkler. So let me give you a little key insight of a Tesla coil. When you cap the bottom, you're trapping heat in there. Heat turns into amps. Amps pushes the field out further. That's what it is. So if you close the top of your Tesla coil and run your wire to the side and you put a cap on it, what happens? There's more heat inside because you're making it hot in there. You're taking away all the coldness of it. You're just making it hot. What happens? The energy expands further and it's hot. So now anything that's, say, 2.5 feet at 11 volts, you shouldn't be touching anything. You should be in tight close to the Tesla coil, right? Mm-hmm. But you're not. You're out here because now I've just expanded it by changing the actual amount of amps in my system. Now, when I open the bottom, I'm now cooling off the center of it. Now it'll run less on the breakout, okay? But it'll give me more energy down the center. Now I can pull more energy out of the center because now it works the right way. Now it's a magnetic pinch to the center. Now I can pull the energy out of it. The difference in the Tesla coil and Gerald's coil is he has windings in there that'll amplify that pinch. That's the biggest difference. He still has two coils oscillating.
Yep.
He has, coil A and coil B.
The Tesla coil principle is in it by far, Nathan. You're absolutely right.
Yep. You still have them oscillating. You still create the pump. It's still there.
I just added to his system. I added to his theory. I basically looked at it like this. Everybody has these systems. They're all different. They work on one principle. But what's the electrical engineers of the world trying to get rid of all the time? Noise and extra heat, and there's so many instabilities that go into a circuit that they ground out or use caps to filter off, or I don't do any of that. I don't even use resistors in my circuit.
Yeah, I noticed.
There's a reason for that. I want that energy to flow through my circuit so that I can control the resistance on my load, because that's where it should be, not in the circuit.
Well, as soon as you put a resistor in your circuit, you're creating heat in your circuit.
Yeah, and you're slowing everything down, right? So you're slowing down that energy that whips through it. And of course, that means, you're getting more current out of the system. But that's not where you should build your current up. Like
that
you said earlier. Yeah, like you said earlier, I have a lot of winds in my coil. You're right. It gives a capacitive factor to it. And then you couple in all those instabilities because it's 180 degrees out of phase. It's a mirror image to the first coil. It's because it's so close together, it creates plasma in between each wire. There's so many different things that come involved. And the fields that it creates, they overlap they push together, they compress, they release, creates a pinch. There's so many different things that come involved. There's like, we're at the point now where pyroelectricity is coming into play. We control heat, turn it into voltage, and use that voltage in other places. So now heat becomes a tool, not a problem. And
Right.
I say that because I believe that in the center of a Tesla coil, right in the center, not at the top or the bottom, but in the center of the whole coil itself, there's a sphere in there. There's an evil in there. Because Tesla was playing with those ideas and he knew about it. That's also what I believe is in a certain configuration in the center of my coil is an evil. It's a controlled evil. Exotic vacuum object.
Check this out.
Go ahead.
I'm going to tell you the secret to that rodent coil with the Tesla coil.
Mm.
Okay, and you already know it. When I put the wire down, you know I'm pulling cold electricity, just so we're all aware. I just told you how it works earlier. What I didn't tell you is the temperature of the room and the temperature of the coil. As my temperature of my coil goes below the temperature of the room, it resonates really well, and it'll stay resonating. When I take the wire out, it'll continue to resonate until the temperature of the coil turns into the temperature of the room. Then it'll stop. Now,
Dun, dun, dun. Sorry, I had to do that. Go ahead.
it's only known if you know the cold side of electricity would you ever find this. Okay? Massively big spoiler there. When you actually can control that, you can start to manipulate how the temperature works in the room to it, whether I pull in more energy or less energy. So it's kind of
sorry. It felt like you should have had a drum roll at that point because that was like mic drop. It's over. Good night, people. Have a nice day. I'm kidding. But that was a very big golden nugget. Could have been a mountain if you were looking for it.
Well, it's the same one that I gave out when I keep trying to tell people you're changing your voltage and frequency to go lower in order to get heat and amps. So when you can understand that in the correct way, now you can manipulate the heat in your circuit in order to get more voltage and amperage out of your circuit. You can also start to manipulate Lenz's law when you start working in a colder circuit than a hotter circuit. And that was shown yesterday with Myke. He was explaining it without saying directly that statement. He is negating Lenz's law in.
Yep. Well, they froze him because they didn't like that. I'll say it. He's negating Lenz's law in his system. I'm sure Nathan will come on back.
Yeah, he'll snap back on. What did you say?
I said, did you want to add to anything Nathan was saying till he comes back?
Oh, about Lenz law?
Yeah, well, it doesn't matter. Yeah, Lenz law, Myke's system.
So the thing I have to say about Lenz law is apparently it can be reversed. And there's a whole chapter on it. Yeah, and there's a whole chapter on it in the Practical Guide to Free Energy Devices where there's some ideas on how it can be reversed. I'm not too well versed on the subject, but I know that there are theories how, like you said, it could be negated. And in some of these systems, I believe that might be what's happening.
I believe that Lenz law is negated when you have the ability to capture back EMF. So what's back EMF, right? Well, when you run energy or power through a wire, you create electromotive force. Well, there's also back electromotive force or counter electromotive force, it's considered.
That opposes the original current that created it. And if you
Yep.
if you oscillated at the right frequency, I think, or resonated right, you can kind of like like a surfer riding a wave, and maybe reverse or negate that lens law. I don't know. That's just the way I'm kind of trying to visualize it.
And that can be done. It's a little hard to tune it because you
Hmm.
gotta create the wave, hop on the top of the wave, like capture it and ride it in, right? Whereas with
Right.
the system that's been created that I use, because I won't say I created it, but you know what I mean. When lens law starts, like when you get that back EMF, as soon as it starts to be created, it's being captured because I give it the path of least resistance. Because how does that counter electromotive force get created? As it's going down the wire or in and around the wire, it's starting to heat up that wire because, like you said, it's going in the opposite direction of the energy that you put in originally, right? So by making a coil 180 degrees out of phase, a mirror image of the first coil, that gives it that path of least resistance. So if the minute you create that electromotive force, it's negated by capturing it in the second coil, bringing it almost to superconductivity.
So in like in maybe a more traditional coil that's not mirrored and has no path backwards of least resistance, whereas that mirrored process, it has a path both ways. That's okay. That's a good way of
You got it,
I'm starting to get it.
That's what made me wonder about the rodent coil and the way you're doing things. I had an idea I'd like to talk to you about offline about that. Maybe a way of kind of changing it just a little.
Yeah, no, I'm open to all ideas because I kind of hit a roadblock. I mean, the Jewel Thief is amazing because a traditional, when you look at the Practical Guide to Free Energy Devices, which Daniel Nunes had access to, he had the Jewel Thief, and the Jewel Thief, he based it off of that chapter. I'm assuming because it was the same circuit, only slightly modified. So I mean. But the thing is, the original circuit only supposed to get 2 times voltage out. This is getting 10 times voltage out, and that's what it said specifically in the chapter. So it's just weird. Oh, here he is. 2 times voltage out. This is getting.
What's up, guys? They froze my system.
And that's what it said. Yeah, they
the minute you said
froze you out. Lens law, yeah, and we were we were trying to figure out what was going on.
But hold that thought for a sec because something came up here. Transient is the condition between two permanent conditions. Okay, so they bring up transients. Vortex says with transients. Sorry, I'm going to miss that. Sorry, Nathan, I'm trying to get this thought out. It's hard because I'm grinding through it, right? Transients are created when you literally... I look at it like this. When you turn your light switch on, the power has to go and fill that whole line to get to your light. As soon as it gets to your light, you shut that switch off. It's got to flow backwards twice as fast as it did when it came in. Why? Because it has to be ready to be turned on the next time. It's kind of how energy flows in a sense, right? So if you're doing that really fast, you're creating transients in a coil of wire. Or partially. Okay, sorry about that. You were talking before you got knocked off, Nathan, about Myke's system and about how Myke didn't want to talk about negating lens law.
Well, it's because it's exactly what he did. He didn't come out and directly say it, but you had to know it was there.
Oh, yeah.
Not only that, he used piezoelectricity in order to amplify the amount going out. Okay? Here's the thing. Just understand this. I have it on my oscilloscope, and I've already done it several times. As soon as you hit the piezo button on cold energy, the entire amount of energy doubles immediately. Okay?
Yep.
Doesn't matter how you're going, which side of the wave you're on, or if you think you're on the down slope or the up slope or the center part. It does not matter. It amplifies every peak, just like that.
Yep.
So when I asked him if it was on his pulse or his coils, now here's the thing. It's okay that it's on his pulse. He's getting part of it, but he isn't getting all of it. So when you delay for a second on your part that's taking in the energy, right?
Yep.
Then pulse that, now you're getting all of it from every single coil, because it has to have the frequency in the coil, then it has to amplify. So we're talking split second. We're not even a second. It's like a microsecond, but it just has to be there just like that. So it's like a boom, boom. You know what I mean? Just right away.
Do you want my opinion on that?
Go ahead.
Mike's genius.
Yep.
In the sense where he stumbled onto something or he figured it out. I'll give him full credit for that, Mike. That wasn't a diss. When he put the piezoelectric in front of the coil and the piezoelectric behind the coil, he created a resonant path that resonates with the whole system. It's a timing circuit. And it's not something we'd see because it's like you said, at the split second. Not on just one, on both. Because remember, when you're running crystals or quartz, and he's using
it's got a beat rate.
Exactly. And it's got a beat rate because when crystals resonate, they resonate with each other and they become AC, right? So what's he doing? He's using it as a timing circuit, multiplying the energy coming through. But that's where it is. Right?
Oh, that's so cool. I wouldn't even, my mind didn't even go to the beat rate, but I know it's there. It's like,
yep.
Absolutely. That's why I told you I would like to take your coil, put that piezo in there and get it to just pop it.
Yeah.
So
try it and find out. Sorry.
Hey man, I've done a bunch of it. So it's only when you do the testing do you find that out. That's what's so cool about it. But it shows up perfectly. I got it on my Gravity Flyer when I showed it. It showed up perfect amplifying the entire thing, man. It just boom. Immediately.
That's a pump. That's an etherical pump or a quantum vacuum pump or
it negates the conservation of energy because of the amplification multiplies the energy. So conservation of energy cannot be used in this system.
Okay, and I agree with you, but it doesn't negate the law of conservation of energy. It actually complements it. Now, I don't have it written on the board, and I'm not ready to give full paper yet, but that's definitely part of it because of the way that it all works. You want to. Okay, so because we're able to control heat and heat differences and potential differences, you're at the point now where it's the most efficient system there is. Okay, we won't say over unity, we'll say efficient. You want a little piece of what I wrote, maybe getting an idea?
Yeah, go for it.
Okay, I gotta put my glasses on because I'm not young anymore. I'm not old, but I'm not young. Or how does it go? I'm old enough to know better, but young enough to still make the choice. All right. So it's been achieved with experimentation, a temperature oscillator with low parasitics and fast oscillations, giving it a self-tuning cycle with an electric field that is synchronized with the temperature signal. By changing temperature and measuring current and doing this over the temperature ranges and frequencies that are relevant for the application, by using sharp and repetitive temperature changes, allows for an increase in the ability to to control temperature while decreasing the ability to cycle, which requires perfect oscillation for any given input of any thermal waveform, which in turn is efficient thermodynamic cycle. So we're not negating the law of conservation of energy. We're using thermodynamics to its most efficient capacity and adding to it. I'm not explaining it properly.
So hold on, but if it adds to it, wouldn't it change it? Because you're adding, because they're saying that you cannot, it's the same energy from one point to the next. It just transforms how it is. You're saying you're adding to that energy.
By changing temperature to potential difference, you're adding to the energy that you're using. But you're really not adding to the energy. I mean more like, how do I put that? You're using it at the highest efficient rate. You're turning temperature into voltage, which apparently can't be done without piezoelectric crystals and all kinds of different factors.
So you're using the law backwards. So
yes,
they're always using the energy going out in heat. So it's always like the expenditure of the energy. You're saying going backwards. So you're using the heat in order to produce more energy, but it's still within the same confined system.
Exactly. What I'm actually doing is taking the charge separation, separating the temperatures, taking the heat, turning it into potential voltage, and then that potential voltage being at a high rate, I ground it out, and going from high potential to low potential creates a current. I collect the current. That way it doesn't cost the system anything.
Hey, Gerald.
Yep.
You do realize right now that if I wrote a law based on the temperature and how to make voltage and amperage, right? That right there, we can write a physics paper.
Yep.
If I told you how to make it work within the conservation of energy, there's another physics paper.
Yep.
If I explain to you exactly how to pull energy out of the earth, okay, I could write a whole nother physics paper. You understand what I'm get going here, right? I could probably write 50 physics papers right now based on just what we're talking about, because we understand not only how it works, but I bet you I could put the math to it in minutes.
I could get into the vacuum and I could go on for pages about how this works and using all the physics terms and all the math, not my math. I'll give shout outs and credit to those that came before me. I stand on the shoulders of 1,000, if not thousands of men. Okay. But what I have was given to me from up above. Right. I'm going to do that out of a symbol there. So, but all the physics is correct. It's all there. But what this system allows the capability of is taking temperature and changing it to something you can use. So solar panels, what do they run at now? 20%? This system runs at 100 plus, I'll say that. Okay, so can you write 1 or 2 physics papers? I've counted 7 on what this system does. And it's not because I've come up with some strange math or some strange this or that. No. It's all there. But unfortunately, because the academic community is broken, they're not allowed to look in the opposite direction. How does electricity flow, right? Magnetism and electricity, or static, whatever you want to call it, right? So it's 90 degrees out of phase. Well, I believe that the academic community, academia, those at the top, the ones that won't let go, I believe that they've become 90 degrees out of phase.
So why don't we do this? Why don't we just get together and write the negative side of energy or the cold side of energy and explain the whole phenomena and then publish it on our own. Just publish it in a newspaper somewhere so it's published. Okay, so that everybody has it. Doesn't, have to be something that academia or whatever publishes. But just so it's out there, and then they can look at it and disagree how they want, but then we'll put the examples of the systems in which parts go with it. So not only do we have how it works, we have the examples of how it works. So you're going to have a pretty hard time telling me that it doesn't work when you can reproduce it easily, or you could just come and visit and I'll show it to you.
And I've had another breakthrough. And I'm not, I'll say this. Solid state. Okay. Solid state energy is out there and absolutely will write the papers. I'm with you on it, Nathan. 100%. We'll do it. We'll go offline. We'll do it. We'll get her done. We'll write all 7 of them that I can count. Who knows? Maybe somebody else will write other papers on this thing. It's going to coincide with Einstein, the 3 laws of thermodynamics. It's going to blow your mind when I give you what I've written and we talk about it, how much it's like 7 or 8 different theories that all these different physicists have, and they all come together. Not all of them is right, but there's a piece at every one of them. And if you take it and you put it together, there's a picture forms. And that's what this is. So, yeah, let's write the papers. I'm in.
So, Ian asks to be sure it's a closed or open system. So, I'll explain it, and then you can explain it, Gerald. So, there's 2 systems. There's a closed system, and then there's an open system. And the closed system doesn't have to be a closed system, and it depends on ground. If you put in the ground to it, it's an open system. If you put no ground into it, it could be a closed system. However, the secondary system runs when the primary system operates. The secondary system pulls in the energy through the flow of the temperature. So I guess you could say it would be 3 separate ways you could do it, and that's the system. So your primary 4, what's the 4th, Gerald? Go ahead. No, I'm not going to tell them.
We'll leave that for the near future because I don't want to step on anybody's toes. There's some people out there that are doing amazing work in battery tech, and I've kept some stuff to myself. But there's 4. Okay. Let's just say this tech can go big or it can go really small.
So do you agree with me on the 3, though?
Yes, absolutely. Absolutely. Yeah. I'll tell you offline about the 4th. And don't worry, everybody out there. I will share. I'm not keeping anything, in my backpack, so to speak. But it's a matter of timing. I share when the time's right because it's like, I don't know. If I teach you how water flows and you've never seen water, I'm just pissing in the wind, pardon my expression, right? So it's kind of that's how I do things. I apologize if I'm doing it wrong, but
we're going to have to get Ben's system to pull a cold energy on it, and it's going to show it.
Go offline to talk about Ben's system. I have an idea that might,
yeah, I think I'm really gonna need your guys' help on this to really unlock the secrets of this coil. Or any coil for that matter.
I pulled that. Yeah, I pulled the rodent coil into cold energy already.
Well,
you do good work, Ben. You're almost there. I think you have a little bit of you're stuck in the box. We got to pull you out.
I am, but I think the modified Joe Thief circuit kind of proves that there's some potential here.
Well, there's a lot of potential.
Mm-hmm. There's potential with the rodent coil too. Don't kid yourself. You found something. I'm not saying you didn't. I think we'll talk up. And if I'm wrong, I'll apologize.
By the way,
Yeah.
one of the reasons I wanted to do the rodent coil is for Ben, because I wanted to show a different experiment than what he normally sees online for these things. And by pulling cold energy into it, it kind of shows you something different. So think of it this way. If I know I'm pulling cold energy and now I ground my rodent coil, now all I have to do is make my circuit pull it through. Okay. So I got to get a negative on a battery on one side. I got to pull it through the system, right? Pull it through that coil. Now I should be able to produce a lot more energy in there without any interference, okay, until I get to a certain amount of voltage. And then I'll get destructive interference. But as long as I keep it under that, I'll get constructive interference. So it'll be cool. I'll have to put the circuit together.
And creates a field. And I'll say this. Maybe you should start thinking of some water experiments.
You know what? I spent all my money for my experiments shipping you guys the printers. Did you get yours, Gerald, yet?
Nope.
Not yet?
Not yet.
Ben got his.
I'm not complaining, dude. I'm like, hats off. You know, like, I appreciate it. I have no words. Right? It's wow. Like I said, I got to do something back for you. Like, just that's.
Don't worry about it.
So, but
I got to create a circuit for Ben and I to use for the rodent coil, because I think if I pull a negative circuit on there, it'll change how he uses it.
Yeah. Yeah, and there's multiple different ways that people have utilized this coil for, extra energy, OU or whatever you want to call it.
Yeah.
We need to, figure it out. That's all.
So hold on. Let me just say this, Gerald. I looked at Gerald's circuit yesterday. You guys all heard me explain it, right? Explained it in positive energy. I made the mistake of not looking at it as negative energy. I say that to you, Ben, so that you can relook at the circuits that they gave you. Did they run them in negative energy when you thought it was done in positive energy? And that would be where they may be they're not pulling the wool over your eyes, but they're not telling you everything that's in the kitchen, if you know what I'm saying.
Because they can't.
Yeah, no, there was
trouble,
there was a recent discovery that I made on their Facebook, and it specifically said in a very calculated PR response, because somebody asked, is this about the advanced version 3 coil? Is this the one that gets the COP greater than 3? Somebody obviously been following their research, and then a very calculated PR type response. They said, we are not marketing OU at this time. Please stand by for further testing or something. So it was very, and it was at the end, it was in near 2021 or 2022 of their, Facebook posts. So it was very weird.
You want a suggestion?
Go for it.
I think that the rodent coil creates fields. Because it creates fields, they've always showed people working in positive on your coil, because from the positive end of your circuit, because they want it to heat up. They don't want you finding out that if you run it in a negative cycle, then your field expands twice as much, and there's other things that you can do with it.
No.
Yeah. Well,
like wireless energy, for instance.
I used one wire energy. It wasn't even connected to my tensor coil to get cold energy in it.
A rodent coil, it mimics the same flow of energy around the top of a toroid at the top of a Tesla coil, right? So if you use the Tesla coil to run your voltage high and then ran it through, I don't know, just saying.
Haven't I been telling you from the beginning the rodent coil is just energy, like the site of energy, like how it flows in it?
Got it. You knew it right from the start, man.
It's a toroidal field. It's showing you what it's supposed to look like. And that's why they built it that way. It's like a gag onto itself. They literally took the field and what it looks like and built a coil to show it.
Yep. Yep. I believe so. And I think that they kept that out of the mix. They didn't want anyone to know that you got to run negative electricity through it, not positive.
Which makes you wonder, okay?
Right?
When you get the time dilation, is it there because one field is moving in one direction while one field is moving in the opposite direction?
Yes.
And they're overlapping each other as they go.
Yes. You can't have time dilation without it, because when they overlap, that's like your intermittent field in between that allows the electrons, protons, gravitons, call it whatever you want, to go from the outer field through that little zone and into the field that you're in, which is a different time or different frequency than outside. Because remember, it's like creating a bubble, like time dilation, a huge bubble, would be like sitting inside of a Tesla coil. You're in one field and the other field's on the outside.
Oh, I had something. So I don't know that this is plausible, but it could be in a certain way. Yeah. If we look at the way that we're looking at the Earth, right? And it's north and south right now.
Yeah.
If you have time dilation going on, the speed in which that would occur would be almost nil to us. In one lifetime, we would not be able to see any movement. But in 20,000 years, the first coil stops and the second coil turns on. Therefore, you could flip your pole immediately every 20,000 years if time dilation was in the factor, right? Because your pump is working in one direction right now. You flip it, it'll turn into the other direction. And only with time dilation does that even make any sense whatsoever, which would tell you it is not Planet X coming. It's simply the planet doing its job.
Yep. Have you ever seen, I don't even know if you can find it on YouTube anymore. There was a guy, he did like dominoes with magnets in a sense, but he had it set up. It was like a tray and he held them. And as he spun one, they all spun in succession. And it was kind of like in a loop. So it made you wonder, well, if one pole flipped in our solar system, would the others flip in succession? You know what I mean? So maybe the sun's responsible. When it flips, all the planets flip.
Oh, I would believe that. Yeah.
I don't know. Just a thought. Yeah.
That's interesting. Because then it would make it's not, I don't want to say it. It would take a lot more force than a planet in order to change the sun to flip. It would be a bigger force than that. You would need a system that's infringing upon the system. And it doesn't have to be right on top of it. It has to brush it. That's it. Interrupt the flow. It interrupts how it travels, right?
Yep.
So if I put a field next to a field and I keep them far away, they don't interrupt each other. But if I move them a little bit closer, just for an instance, they'll immediately affect the other one. Then I can pull them back apart. That's all it has to be.
You're not wrong. Yeah, I think we're going to find out some new things about planet Earth and our solar system in the next coming years. If this tech has anything to do with how everything works, let's just say they've left some stuff out, or there's stuff they didn't know.
Yeah, well, I think there's stuff that maybe they didn't know, or some stuff they put in there and got removed. I think there's a lot of stuff that gets removed out of this stuff.
I agree 100%. So back to cold electricity.
So cold electricity is basically dark energy. That's all it is. And
That's what they
You
call
think
it.
that cold electricity consists of ball lightning or has any way to do with ball lightning?
I think ball lightning is the catalyst between cold electricity and hot electricity contained within spin.
hold on. Now you're getting into dark mass.
Ah, see,
Okay.
but I stayed out of that whole dark energy thing because that to me was the physics community trying to slap a name on something that we already know what it is. They
Yeah,
just
but
don't want to admit it.
Well, hold on. It makes sense, though, that you go to dark mass because as soon as you go to that ball lightning, you're creating mass based on the energy, based on any gases or anything around it. You're pulling it in, you're creating mass. That's how you get dark mass. Dark mass will then turn into planetary forms. Some things will form in the sun, depending on how they form together. That's the answer right there. You just completed the other half of their loop there, Gerald. It's the side that goes from cold energy to hot energy that creates the mass.
Yep. It's the missing part of the equation, the missing link. Like these people that believe we come from monkeys. It's the missing link. I'm sorry. I can't make fun of it enough. You think you come from a monkey? Really? Well, my aunt must come from a fucking rhinoceros because her ass is as big
Hey,
as his brain.
I was once told I was a monkey's uncle.
Well, there you go. There you go. I just can't believe in that. I won't. I don't. I think it was a diversionary tactic to the truth of what and who we really are. That's just me. And I think those that believe in it, hook, line, and sinker, I mean, all the power to you. I'm not trying to fault you. I just think that you've been fed a line of crap and your teeth are brown.
Well,
Sorry.
they did anything they could to not give credit to the big man upstairs.
Yeah. Hey, don't get me wrong. I've eaten some brown stuff myself and I've made mistakes, but yeah, you're not wrong. They do everything they can to take away the credit from upstairs. Like, I can't remember where it was I heard it. It might have been Sabrina Hassenfetter or somebody else that said the physics community, I think it was somebody else, the physics community will do everything they can to state that they were the ones that did the work. They were the ones, they went to school, they busted their ass, they did the exams, they didn't sleep, they worked very hard to get their degree, and now they have a PhD and they're an accomplished professor. Okay. So what does that mean in the big scheme of things? You can regurgitate that which you're told.
Yep.
Because if it was any different, you would have found that which I've found. I'm no different than anyone out there. I'm not special. Like anybody could have found this, but you got to think outside the box. You got to be willing to get shocked, and you got to do the work. That's it. You got to do the work.
All right. So, by the way, I find it funny. There's a lot of people out there. I was watching a show today, and they were talking about they didn't understand why nobody can replicate some of these circuits that have over unity to them, right? And I'm laughing because I went over their circuit. So they showed the circuit, right?
Yeah.
And they go, we ran the circuit. We can't find it, right? And I'm going, did you run it the right way? Because you're assuming things that are not meant to be assumed, just like I did to your circuit. So if you run it in reverse, okay, then you go, okay, well, now it starts to make a lot more sense in the actual circuit that was built.
I loved your comments, by the way. Those were the best because those are the kind of comments that come from an electrical engineer, and not don't
go for it.
This is an insult. That would look at the circuit and go, okay, well, that's an NPN. So why is he running a coil from the back end? You're supposed to run it from the front end because that's your positive And if you, just like what you did, it was perfect because I didn't let on that I flipped it inside out.
Okay, so check this out. Just so we know how this works. When you get a transistor, this is your pulse side right here, right? This top one.
Okay.
This would be your collector and emitter. Now, all you're doing is you're pushing this upon here and creating the field in which connects them. That's it, right?
Yeah.
I can't even hold the pen. Okay.
You lost the field.
So what Gerald's doing is, even if he runs it in reverse, he's still pushing it down, right? Yeah. Push it. And he's just fucking pushing it down, right? That's all he's doing, and he's making the connection for it to flow. That is literally it. So when you start talking about NPN and PNP, just understand that was the whole connection right there, okay? And that's what 90% of the people don't understand. Because why? Because when they start explaining these things, all they start telling you about is some, oh God, I can't even think of what the words were. I roll my eyes every time I hear it.
The electron flow in the depletion region has to have the full amount of electrons in order for the electron flow to be completed. Sorry,
there you go.
I had to do that.
As soon as I hear that, I want to vomit.
Yeah, me too.
I just literally like, dude, this was so much simpler. You know what I mean? They've never.
I'm glad I never got an electrical education because. Yeah. Thank you. Sorry, guys. I'm glad I never got an electrical education because I couldn't have done this work. I would have thought along the lines of an electrical engineer. They're literally taught to get rid of this stuff. They can't have it. It's bad, you know. But if you're looking to what they're not or what they're trying not to do and do all that, you'll find this.
Well, if you applied field theory, okay, just the theory of fields without electron, then a transistor makes 10 times more sense. Like I showed you with the markers, as soon as it comes down, all you're doing is you're impressing one field upon two and making all the fields flow together. That's all you're doing. Okay? Not some depletion zone, not a bunch of stuff wiggling to the other side and shaking hands and fucking it just you're not doing any of that.
Yeah.
You're just moving fields. That's all you're doing. So
absolutely.
It's literally retarded. And it makes it hard to understand. You go, well, then why can I pull a negative out of a positive circuit? Because they're fields. They don't work like, you know, electrons. They just don't work that way.
I think electrons are the two fields crossing, right? But they say it's an electron flow that creates the field, allows it to cross.
Okay.
They make it confusing, but literally it's just a field of flow.
Let me explain this. Here's your marker. I'm going to cut it in half. Okay, say this is a half on the top and this is a half on the bottom.
Okay.
If this is all positive, it just basically means that there's more charge on this side than there is on this side. That's all that it means. When I run AC, I swirl the wire. So what am I doing? All I'm doing is collecting more charge on this side, less charge on this side, more charge on this side, less charge on this side. You could still use each one. That's all it is. When you get into DC, there's a field here for your amps. There's a field here for voltage. So when you pinch it, you're putting energy into the wire itself in the form of heat. Then you take that heat and you transform it back into energy and flow back again. In a perfect system, there's zero loss. It is a simple way to understand it in fields that you don't need electrons everywhere.
No. I guess they're a good way of explaining things when you're making things confusing in a way. I don't know.
Oh, it's confused a lot of people.
Oh, big time. When I started learning that, like I got books from electrical, I got DC electric theory, I got all that. I picked it up, looked at it, and went, this is stereo instructions. Like, whoosh, give me some wire and a battery. Let's have some fun. Right? And then course, took off from there. But yeah. Don't get me wrong, DC theory and all of that has its place. You're not going to wire a car stereo on this kind of, right? But
Okay, hold on. Ben's over there making crumples. Here's why you have to know how it works that way. Okay, just understand. If I want to capture a field inside of a field, if you don't understand Steinmetz and how amps and volts work, you'll never be able to capture the field inside of a field. So when I tell you I'm using my Tesla coil field and I'm telling you I'm using a DC high voltage field, are they much different? No, they're just not. What's different is my frequency. What's different is my amount of heat versus my amount of volts. Now, I can either take it and take the Tesla coil field right here and hold in my high voltage, or I could put the high voltage on the outside and I take my Tesla field and push it out. That's how fields interact. If you did not understand the amperage part, you wouldn't know the direction of each one. The more heat that it has in it, the field stays inside. The more voltage it has, the field stays outside. I can manipulate the voltage with the heat. Now I could take the heat and the amps and I could put it in the field and inside, and I could take that voltage field and throw it across my room. I can fill up my entire room quickly just by knowing that simple fact. That's it. Or I can sit and contain it. Sit there, contain the energy, not a problem. Now, that wasn't hard to explain. It's not hard to hear. It's hard to see it because you can't see the field, but the effects of the field you'll see everywhere.
Yep, you're absolutely right. Vortex said it. Well, I missed it again. Here it is.
What? I missed it. What does it say?
Dark sea, dark energy, or Dirac sea, dark energy. Take your pick. Yeah, the certain individuals in the scientific community have been bringing up Dirac sea a lot. And they love to talk about how basically free energy would work. But, and I'm not saying they're describing my system, and I'm not trying to sound egotistical. Please forgive me if I do. But they're talking about my work. Not directly, but that's exactly what they're describing is needed for free energy. And I hate using that word. It's such a bastardized word. Over Unity's even become that. I would have to say efficient, 100% efficient about that. That's probably more along the lines of being correct.
Well, hold on. You said earlier most efficient system, but let me disagree with that, okay? And not in the way you said it. It has to do with the energy of the room, because they're not talking about the energy in the room. They're talking simply about the system with the original system connected. That's the system they're talking about. So in that case, I agree with you. However, the secondary system is 100% way over because it's taking the energy from the room.
Okay, but when I talk about system, I mean the room is part of the system. All heat, all cold, all light, everything is part of the system. You can't have the system without it.
Well, then you have to take into account time dilation as soon as you open up it to an entire room. As soon as it goes to a whole room, because you're creating a heavier field around the room, in the room that you're in. So
But
now,
go ahead.
no, it's going to say now it's going to change the time between that room and the next room. Okay.
In order for that to occur, it takes actually quite a while to build up a field that big. You know what I mean? So it's not like it's any one person can just do it willy-nilly. You know what I mean? They have to kind of know what they're doing, and there's certain configurations, and it takes, you can't just plug it in and flip a switch. All of a sudden your field's like, boom.
No.
You literally, it takes time. And what happens is your inner bubble. So your outer bubble and your inner bubble are created almost instantaneously upon turning the switch on. Then your outer bubble, as you're starting to fill the system, electricity, pulling a load, doing certain things, right? Your outer bubble starts to grow really fast, and then it stops. And your inner bubble grows really, really slow. When your inner bubble reaches the same size as your outer bubble, and I'm putting this in layman's terms, something occurs. And that resonance that happens at that point when the outer bubble reaches the inner bubble gives you time dilation. But it can't happen until those two come into contact. And there's a long period in between those two build up. So
depending on your bubble size, okay, if I wanted to create a bubble this big, right here, okay, 10 minutes.
Yeah.
That's about the time it'll take me to create that size bubble.
Yeah.
Now, bigger than that, room size, way longer time. Okay.
Yeah,
Could take hours.
It's exponential, right? It may take you 10 minutes to get here. It may take you an hour to get here. It may take you 10 hours to get here. I'm not saying that's the numbers. I'm just saying as an example, right? Yeah.
Well,
I don't know the numbers.
A lot of people wonder why Alexi waits 10 minutes and before he starts pushing a button. I can tell you why, because he's building the field. And
exactly what he's doing.
He's just waiting. It has nothing to do with anything else. He's just waiting for the field to build. And I try to show in the ultrasound machine, because the transducer, excuse me, not transducer, but the piezoelectric disc is a receiver and a transmitter. You're going to hear the energy in your ultrasound device. That's the key. When you hit the sides of the field, you're going to hear the sound. Yep. That's how he knows. That's exactly how he knows. And he doesn't have to worry about how much energy he's putting into it. Please understand this. The amount of energy he puts in it is simply a suction. That's it.
It's a means to an end.
Yeah. He's not filling it with it. It's a suction to pull it right out of the ground.
Okay, so I'll give you an example. It would be like the video I do when I turn the system on and I'm running it, and then I shut my function generator off and the system stays in resonance and it keeps running. That's what Alexi's doing. He's powering the system up, letting it build the field. He creates a resonant field in the area. And basically, when he goes to what I would do is shut off, he's actually hopping it, punching the field to the point where he can lift. Does that make sense?
He's adding that little bit of heat to the system and changing the positive and negative as we would know it, or more or less energy, and flipping it. That's it. He had a little bit of heat to it.
Yeah. He's tickling it with the heat.
Yeah. So think of it this way. You're creating the environment of the Alps on the ground, and then you're just adding a little heat. So now it's easier to lift, just like your hot air balloon. It takes more to get off the ground than it does to stay in the air.
Yeah. Yeah. I just realized something I got to test, but I can't say it. I got to test it.
Another one.
I don't like.
Sorry, guys.
Ben,
I was just gonna say I got my new neon lamps.
Nice.
Okay. Nice.
Multicolored ones this time. So we got Krypton for green and Krypton for blue and Argon for green, along with something that produces bright white. And we have the classic neon, and then something that produces more of a yellow color.
And those are in neon form?
Yep. These are all gas.
Really? Where'd you get those?
Yeah. I'll send you a link. I'll send you a link. The vendor needs to re-up on Amazon, but they do have a bunch left on eBay. So
nice.
Yeah, they're really cool. It was like $20 for 50 of them, 10 each.
Worth it.
Yeah. And I'm all out. So this is really cool. I just tested them all out. Bright white, bright blue, bright green. So cool.
Oh, I want them.
You're gonna have fun with them. You're gonna have fun with them. Trust me.
Yeah, I'll see if I can
Sorry, I
get
didn't.
like each of them.
Yeah, exactly. That was my but I didn't mean to get you guys off topic. Just got excited about that.
No, not at all, Ben. You're part of this conversation too. You've just been kind of quiet today.
Yeah.
Yeah.
It's because you don't have your hey, you don't have your
Oh, my lab coat.
yeah, you
The
don't have
lab
it
coat
on,
gives
Ben.
me the lab coat gives me the confidence.
It's like your cape. You gotta have it.
Yeah. Nah, I just having an off day today, honestly. Low energy.
I hear you.
We'll show Ben going into a phone booth and getting his lab coat on and his hard hat. You know what I mean? It's like
Yeah.
Superman.
Damn straight. And all of a sudden
The
he's
safety
getting over
glasses
Unity,
too.
lifting trucks up and stuff. That would be a good video, man. I would love to see that.
Oh,
Hey, we're gonna make some fun videos, I promise. In due time.
That's great. You should.
hey guys, I want to show you this. Have you guys seen this already?
Can't say that I have.
Okay, you've seen the coil.
No, what is this?
Mm-hmm.
Hold on.
This
Let me
Ian's
play
coil?
it for you. This is Ian's.
Oh, that's where I recognize
part of the
that
crew.
coil.
So let me put it on closed caption because I never can hear anybody.
Hello, just a quick update on this. I think I'll call it the cornea coil. So I've built some more solenoids to go around it. They're all the same as the original one that I tested before, and they're two are going to different rectifiers, and then being put into their 10 microfarad caps. And so the four in the middle are producing 200 volts at about 40 milliamps. The two on the outside, the two pairs, are about actually showing 54 and 60. And again, there's 40 milliamps measured on that. It's using this, and I'm not sure if it's correct or not, the amperage, but I'm just going with what it says for now. And so there are three separate pickup sets. There's room for three more sets of two on the outside, three more pairs. That would actually increase that. So you got about 430 volts there. That's for the power supply is only 12 volts input, 1.75 watts, and 24 volts on the square wave. It's 50% duty and 66.6 kilohertz. Here's these bizarre waveforms. The output from the coil is the top on the yellow. The amber is the base of the transistor. And blue is the output of the four in the center. Just to look at the waveform, and the bottom is the current coming out of the coil, the center, the actual coil itself. And wattage, and the wattage for the signal generator and the power supply is 10.4 watts. So yeah, potentially more than that going on here. Interesting point is, though, that as I add the solenoid coils to the center, the power supply draw, it started, the control wattage was 2 watts, and it just gradually crept down as I entered more coils into the around this center.
Exactly what we see in Michael and Gerald's coils.
So that was kind of bizarre. So it's for free. Anyway, thanks.
I noticed a slight difference too as well, but not. It was inconclusive. So
Ian did it. Ian, you deserve this. You did it.
Yeah.
Awesome. You seriously did it, man. I'm telling you.
That's good.
Yeah.
Hey.
That's awesome. I make fun of myself all the time, guys. That's what I do. Sorry. But Ian, that's great, man. You got it. So don't worry about what your milliamps are showing. What you have now is a potential difference that you get to play with. That's what will allow you to create your current by capturing the flow of that potential difference. Keep it up, man. You're there.
So
That's awesome.
real quick, this is Ian's channel right here for everybody to go on and subscribe. You can see Ian's coil on there and what you just saw. That's the first video he's put up, and we're looking forward to more that he does because that's only one of Ian's coils. Ian's got like 7 or 8 different coils over there or more.
Yeah, he's been working hard.
Yeah, I'd like to see more of his work for sure.
Okay.
Oh, sorry.
Hey, what's up, Elijah Tack? How you doing? He popped in to say hi.
Right on. Oh, hold on. Hold on. Try 50. You got 50 coils.
Okay, it's a race. He's trying to catch up. That's it. I'm going to reach 300. I'm kidding, Ian. I'm kidding.
Oh, all right.
Good for you, man. That's great.
Oh, man. He says at least. So now we're going to expect a lot more out of you, Ian, as far as your channel goes, because you got a lot to test.
Pump it out.
Right on, guys.
But then, okay, so in Ian's defense, I don't know if they all worked. I know, like I have said before, I've made 180 coils at this point. Maybe a little more. But not all of them worked, right? So showing them was kind of, I could show the failure, but what's the point? I know I failed. I'll tell you I failed. So I'm not saying Ian did. I hope all of his coils work. But
well, I think in the end, Gerald, once you're done explaining everything, you could tell everybody why they failed. Because there's a certain combination of wiring that you put in there that is a failure. So maybe after you're completely done explaining everything, you could go back to that.
Yeah, there's a certain principle that's in all of these that seems to work.
But that's really cool, man. I love that. Ian, what I want to know, though, Ian, on the next one, if you could put the circuit that you used, because I want to see how close it is to what we're all using. So that'd be an interesting thing, because I would imagine it's going to be somewhat the same.
I would think so.
There you go, Gerald. Right there. There's your golden nugget you gave him. He absolutely used it.
Awesome. I'm glad to hear it. Yeah. Glad to hear it.
Well,
glad I can influence you, help you out.
Which also means that he understood how to not cancel fields out while he built it. That's two. That's 2 nuggets.
That's why he got the dance. Not just anybody's getting my butt shaken, okay? That was awesome. That was awesome. Oh, the circuit helped too. I'm glad. The simple positive impulse circuit. You need to try the modified Jewel Thief one. I have a feeling you might even outdo some of my coils.
Yeah, we've been having fun with that one.
Yeah. I want that circuit to go viral. Everybody should have that circuit.
I know, right? There's so many different configurations that people have too, that there's this one I found today that I want to try it out that supposedly, 8 times output, but we'll test that,
Yeah.
Ben, I think we got to work on pulling that negative through the circuit. I'll work on a circuit this week.
Yeah.
And see if I can't pull the negative on it, and I'll share it with you, and we'll work on it together.
Oh, that would be a great subject for one of the workshops. You can walk me through the circuit and all that, and explain the current flow. And that'd be fun.
Yeah, well, it'll help the research out a lot, because the one thing you'll get along with that is that next step, that ozone step. See, I don't think you're getting it out of the positive. I think you'll get it out of the negative, though.
I think you will too. Yeah.
You might be right. Yeah.
Yeah.
Because I would be able to smell it, I don't know.
Yeah, trust me. Immediately when I turn on my Tesla claw, I smell it. it's immediately there. So,
did you catch Ian's comment there? Wants to present on Wednesday if we have room?
absolutely.
Absolutely. I
Absolutely.
agree 100%. Yeah.
Oh,
I'm
yeah, I
looking
look forward to
forward to it.
Yeah. Sean comes back Wednesday as well, so he's going to present first, and then Ian right afterward. It's all you.
It's all my brothers from another mother's.
Absolutely. That'd be really, that's going to be cool. Okay, now I'm excited for Wednesday. We got both cool guys coming in and running the show for us. That's awesome.
Yeah. I'm not showing anything on Wednesday. I'm just going to just be there because I want to see what they have to present.
But Ian already got a head start right there. You see where he's going. Absolutely.
You got to slap some like a load on there, some low-level LEDs to start with, and then increase your load as you go. In your system, if I'm right, your resistance should define how much power is going to flow through your system itself. Not sure, but something to try.
So what we're going to have to do, Ben, so this upcoming Wednesday, we're going to let them do it. We need to have our stuff together for the following Wednesday so that you and I can take care of the whole show. And you know what I mean? We'll just run things on that coil all day. I'll have my setup complete by then.
Oh, yeah, that'd be fun.
Is that a blue neon or a
That is.
krypton?
Yeah. It's almost purplish, almost.
That's beautiful.
You got a pair of sunglasses, Ben?
Yeah, I think I do.
Yeah, you should be wearing them.
No, it's not that. I wanted to see it through the sunglasses, through the camera. I want to see if it changes the light, so it's easier to see.
Oh.
Yeah, I want to order a pair of those wine glasses off of eBay. They're cobalt blue, something like $65 a piece, just to see if it'll work for what we're talking about.
Oh, what's that movie? Nicolas Cage, National Treasure.
Yeah.
He takes those glasses and he has different colors that come in.
Yes.
Yeah.
One of those is cobalt blue.
Yeah.
Yeah. Oh, wow. Okay, so I got to show this, guys. This is
hold on. 1 second.
This is from my chef daughter, okay? This is chicken fettuccine alfredo.
Very nice.
Nice. You're making me hungry now. No, yeah, that's awesome. I love a good.
Yeah, I'm very lucky.
She's
training to be a chef, so it's like
Vincent's over there showing his ass again.
Oh yeah.
Every time you're in your lab, Ben, you get the same view.
I'm gonna have to have multiple camera angles.
He
But it's all gonna show my ass.
said, "Oh, delicious."
I think he was talking about fettuccine, because the timing was awesome. That's great. Yeah. I love our comments.
Ben OnlyFans.
Go, Ben, go.
Oh.
Oh, man, that's hilarious.
I said about the food.
Yeah, he was talking about the food, I'm sure. Yeah. That's great.
Oh.
That's the
Gotta have fun with life. Gotta have fun.
Well, he does have the stripper lights over there, man. He's got a whole mood going on.
Right? It keeps changing them out. We just need that beat frequency.
Yeah, we need to have a beat. Put on a beat.
Yeah, I'm not a beat bopper, sorry.
He's got buns with his fettuccine.
Hey DJ, spin that.
That's funny.
Oh.
Oh, here we go.
Ben's after dark videos get very blue.
Yeah.
I'm about to make it green in a minute.
Oh,
That's it, Ben. You got to keep your lights on from now on.
oh,
Awesome. Yeah, you
Oh,
have to give me that link, Ben. I need that. I want those. Those are like,
Yes.
look like the cat's ass. Look at that blue, man. That's beautiful.
yeah.
Oh no, that's. Don't
that
pay
something
attention
else?
to these.
Oh, okay.
Yeah. The blue's not in there right now. Right now, I got the
Still pretty
traditional
cool.
neon. Yeah. I don't
Those
see
are
anything through the sunglasses.
Those are trigger switches. No, it's just a filter, Ben, for the camera.
Oh shit! Maybe a little bit. Oh, that's weird. Interesting.
Okay. Well, we don't see much of the light. We see your ass.
Yeah.
Well, you're gonna continue to see it for a minute. Just hold on. Just bear with me. Bear with my bare ass.
Bear with you, eh?
All right.
Here with Ben. He's
There we
playing
go.
with his lights.
Yeah, hold the backfires, please.
I didn't see anything unusual. A little bit of pinkish color, but it's just I need to tune it with the resistors a little bit more.
Yeah, we got pink and brown on this side.
We got dark holes. We got. We can go so many places with that, right?
Just trying to see if I can make Gerald laugh while he's eating. See if he spits it out.
You're getting into the contest that my family does.
Oh,
That's awesome. You're gonna see it 3D camera wise. Yeah.
oh
That's it. I'm not
man.
shooting anymore.
Oh, that's amazing. So Ben, you're gonna record that in the next couple of days with all the different lights?
Yeah, I'm aiming to record a follow-up video to the 0 Point Energy video with the theory and all that, just with some of the updates of the coil. So
Nice.
I don't have a time frame. I'm gonna aim for the next week or two to have that out, and
Nice.
I still have I still have another video to put out of Michael's circuit. Just need to touch it up a little bit and add the intro and all that.
Is Michael's on it explaining it again? Is that what's happening?
It's just the circuit. It's the one that we've already seen. I just didn't put it up there. Yeah, but that's gonna be up on my channel soon.
Victor, you almost got me. I almost spit it out, man. I'm sorry, man. I wasn't ignoring you.
I was gonna put it up, but I don't know that we were allowed to show that.
Oh, sorry. My bad.
Actually hit the brown point right on the head.
I'm not doing it anymore. I'm gonna lose it.
Just don't hit the brown note. Audience will not like that.
I don't know, bro. That's great. It's not a competition to see if I can spit my food out, okay? You do that enough around here.
Oh,
Yeah. I got stuff to show, but I think I'll wait a little bit. I've been doing Brown's gas. I love it.
oh, they're good at this. They're good at this. They've been hanging out with us too long.
Hey,
Hey, we got
you don't
the
want to
black
excite
hole
that
producing
gas.
Brown's gas.
Yeah, you don't want to excite that gas.
Yeah. That could be bad.
Oh man.
That's great.
You get a bunch
As long
of
as
poo
you're not
plasma.
eating beans, it'll be okay.
Oh, it's so terrible. Oh,
Yeah, we're gonna get in trouble.
oh.
Yeah, someone's gonna come in right when I say poo plasma, and they're just gonna be like, "Nope."
Because Combustible
There's no
Benny.
science there. Kind of a shitty situation, I tell you. No. So yeah, doing tests with the globe, the sphere. Whoa.
Mhm.
I can't wait to show that, but I'm gonna wait. Like,
Okay,
That's
so-
your spherical coil?
Yeah.
You didn't show anything on your channel about it, so we don't know anything about it yet.
I talked about it on a live when
I know you talked about it.
yeah, when Sean was making his Tesla sphere, I came up with a schematic for running wiring in a geometrical form that forms a sphere. And it took me a little while, but I got it done. And it's interesting.
So we saw the donut one that like this as like C-shaped and but toroidal.
Yeah.
We saw that one. So this one's like that, but like this.
Okay, so the last one that I made that had that cavity on the inside. So the very last one I was testing with.
Yeah.
Picture that, but extended in the middle. Okay, so it forms a sphere.
Yeah, so it's like a C-shaped on both sides. Yeah.
There's an open hole on the bottom and the top. Just like what I believe the Earth might be.
Oh, it makes sense. You got two holes.
It's not Canadian.
Not Canadian.
Is there more holes in
Canadian
Canada?
has 3 holes.
Oh, so bad.
I know, I'm sorry, I'll stop. But yeah, it's a interesting coil. So we'll get into that maybe maybe next week, because I want to wait for Ben's to finish, and then Victor's presentation and all that. Or not Victor's, but Ian's, sorry. So yeah, I'll put mine off a little bit more. I don't mind.
That's the
I'm explaining it with the other coils anyway, and it's based all on the same principle, but some do different. They have different functions than others, and I'm sure Ian's starting to figure that out.
Gotcha. I'm gonna show Ben's thing solo real quick.
Okay.
While we're commenting, because he's got that light going, the blue one. There you go.
I'm about to swap it out for the others to show you the other colors real quick. I believe that's argon.
I'm not sure. You could be right.
And I think the green is krypton, if I'm not mistaken. I don't know what the white is.
And which one are you putting in now?
I think this is the green one.
The green one?
Yeah, they all look the same unless they're in the little baggie. So
It's so quiet.
Oh, sorry. I'm just watching Ben arrange the bulb in there and get it right. There we go. We have ignition.
nope. 1 second.
Nope. Yes. Maybe.
Main man in the box lost says phosphorus is white.
Phosphorus. I think something got unplugged. Hold on.
I have a neat story about phosphorus, but has to be told off air. It may not go over well with the algorithm.
Yeah. Let's not do that.
That's a good question right there.
Dark matter? Well, we were discussing that earlier. That's when the cold energy and the hot energy mix. Remember?
Yep. Yep. Yeah, that's where ball lightning meets.
I don't know why that light came on. Anyways, this is the green
Powering
one.
the system, sir.
Oh, I see the green now.
Yeah, that's
Yeah,
gorgeous.
the light came on the camera. I don't know how to shut it off. I shut it off a second ago.
No, it's fine. We can see good.
Okay. Yeah, that's the green one.
Yeah, that's a bright green for a green.
Yeah, it's nice.
Yeah. And that's only at 7.9 volts. We can turn it up a little bit. Because this one can handle a little bit more voltage, the green one.
Those aren't 90 volt.
Yeah, that's a 90 volt starting voltage. So it can handle up to like, I think 100 and something. I have to check the baggie, but
Right.
it's rated a little bit higher than the traditional neon.
Do they both have the same starting point between the blue and the green?
Yeah. Yeah, I think they're all identical. They all look exactly the same. The only one that looks the only one that looks slightly different or is the orange and the yellow, I think, don't have the white coating around it, around the glass.
Wow.
Yeah, they do get hot too. That one's hot.
I'd love to create ball lightning and put it in one of those just to see what it's going to look like.
Yeah. And you know what? This isn't because I have a resistor in here, not the potentiometer. If I had the potentiometer hooked up, I'm sure we would see some weird stuff with the white one, maybe.
You might be right.
Just because, white's such a good, base.
But I wonder, though, because it's different elements, is it going to require different energies in order to achieve that? I don't know.
I'm not sure. Let's put the white one in. I'll show you the white one real quick. Yeah, it might require different energies because it's different gas.
Be an interesting experiment.
Yeah, they all look exactly the same. So, but this one's the white one.
One of these things are not like the other.
Yeah, we gotta deck out our systems. Oh, that's nice. Okay.
All right, what do you got?
All right, so I'll turn it off and then turn it on. That's the neon right there.
Oh, yeah.
It's white.
That's pretty white.
Yeah, bright.
And that's a neon.
Yeah.
That's cool. Or phosphorus.
Something in there. Yeah, I'm not really sure what's in there, but it's getting real excited. But yeah, no, they're real cheap. So if you're looking for some cool neons, I highly suggest them to deck out your system a little bit. I think they look really nice. But again, it might be harder to see the ball lightning phenomenon with some of the other ones. So, but they do have the traditional neon in the pack. So,
That's cool.
Yeah, I just thought it was cool. I wanted to try to deck out my system a little bit and experiment with different colors.
Hey, Ben, did you buy your shirt or did you have it made?
Oh, this is on my shop.
Oh,
So
so
Streamlabs makes it. Yeah. You could buy one off of Streamlabs.
Very cool.
Yeah. Yeah, this is
that
my
part
favorite
of your merch?
Yeah, it's part of my merch. It says, I don't trust words. I even question actions, but I never doubt patterns. And it says, Vortex Mathematics explains the mirror. Explains the mirror effect, which generates fractals and all forms in nature.
Awesome.
Yeah, it's a
Very
really
cool.
cool t-shirt.
What's on the back, Ben?
The logo.
Nice.
Yep, that's super cool.
Yeah, I like that, Ben.
Yeah. Thank you. Yeah, anybody who wants one and want to help support the research that I'm doing, it's a good way of supporting my channel and getting something fun out of it.
We don't like fun here. We're about work only.
Yeah, we're a bunch of schmucks.
Schmuck.
Captain Schmuck.
Schmuck.
Captain Stubing.
Schmuck.
Jack's great. I'd love to have him on just to hear him call me a schmuck.
Hey, Mike's here. What's going on, Mike?
Hey, Mike, what's going on? Mike did an excellent job yesterday with his whole presentation.
Yeah,
I loved
watched
it.
I think he had plenty of practice after the first time when he went dead on the channel, and then got it out the first time and was able to come back and do it again.
You know what? I was
Hey,
thinking to myself that last night. I was thinking that must have sucked, but then that's perfect practice. Like he was all warmed up and everything,
Yeah.
right?
Oh, yeah.
Yeah.
It's happened to me, and specifically when I was really nervous about one. And then, like the second time around makes you a little less nervous.
Hey, Ben, you want to put your channel in the description so that he can go and purchase your shirt?
Oh, yeah.
Victor's right. Schmuckers used to be a jam and a jelly company. We still have it up here in Canada.
Don't they still have that? No, they've replaced it at Knott's Berry Farm. Okay, never mind.
But it's
Schmuckers.
not like Captain Schmuck.
Schmuck.
You say it better. Schmuck.
I gotta say it right away after you say it, and it has to be real short and concise.
Captain Schmuck.
Schmuck.
Quick. Yeah.
Oh, sorry. That whole thing, I just remember the video was absolutely hilarious.
Absolutely. And you know what? Here's the thing. I don't think Jack should take that as an insult. That's gonna go on for years. As far as I'm concerned, Jack Sarfati has literally coined the term "you're a schmuck."
That's right. Admiral Schmuck.
That's right. So if anything, Jack, you'll be known for that. How about that?
Hey, at least he got the Admiral title with it.
There you
know
go.
what I mean? He wasn't Ensign Schmuck.
Yeah, there's no other admirals around here. Right, Jack? You're at the top. You're top schmuck, bud.
That's right.
You got to admit, though, he said it all when he said, "You're all schmucks," but you know what? I'm the biggest schmuck. So just, and when he goes on, right?
That was gold right
hilarious. There. Yeah.
Oh, that was the best.
Yeah, absolutely. So it's we're at the 2-hour mark here.
Yep.
Yeah.
We're about done, guys.
Just
So
what I would say, yeah.
anybody got anything else going on?
Ben? You're muted.
So, yeah. So, right now, we're going to be testing with the system I have. We're going to be testing different circuits, specifically probably different versions of the modified Jewel Thief. That's basically what I got going on right now. Nothing really groundbreaking or epic at the moment. Just trying to get all the efficiency out of the system as possible. Right now, it's at 87.4% with the MJL21194G transistor.
Nice. Very good.
That's basically it.
And upcoming, we have on Wednesday, we have Sean and Ian will be presenting. And that's going to be really awesome. So I can't wait for that. Sean, hope you feel better. I talked to him just today before the show, and he's actually up and around and doing really well. So
good.
Sean, we'll see you on Wednesday. And then also Ian, we'll see you on Wednesday. And then I think that's pretty much it, right, guys?
I'll have my hat on and I'll be ready. Sorry, guys.
Real quick. Next time I go live, I will have some interesting new information on specifically the PoE coils. So that's all. Next time I
Very
go
cool.
live, look out for some cool stuff that I have.
Yeah,
Nice.
and I'll bring out the sphere, the globe, like I said, but it'll be next week because I'm going to give Ian and Sean their day and kind of stay out of it. So
Yeah,
bring it. Oh, hold on. No, you don't have to wait that long. On Friday for the next 2 weeks, we're going to be taking over League of Extraordinary Inventors for Myke.
That's right.
It's an honor, Myke. I love it.
So
Yeah.
we can't get all that rowdy on there. Myke already told me. We
Okay.
keep it respectful. So
We'll get you a printout, a mask of Myke, and put it on you. We'll just wear a
Oh,
Myke
that'd be
mask.
awesome. I should try that. That'd be awesome. We should all wear a Myke mask.
yeah, so guys, look for it on Friday. We'll be streaming on Friday for the next 2 weeks until Myke comes back, and then he'll take back over everything. So
after 2 weeks.
Yeah, if you got something to show on Friday, let's do it, and we'll get together with Phil and everybody from his crew, and you know what I mean.
I'll try to get something together. Yeah, I'll try to have something.
Yeah. I'll do that for sure. That'll be awesome.
Right on, guys. With that said, thank you guys. Thank you, chat. Thank you, everybody. Thank you, Gerald. Thank you, Ben, for coming in and doing all this with. So
love the comment section. Don't forget to subscribe and like. You guys are the best out there. Without you, we couldn't do this. And Admiral Schmuck.
Absolutely, Admiral Schmuck.